All right, more fun. Let's take a look at number 7 and number 8. So, 7, the principal at West Elementary School randomly selected 15 weeks from the 2020-21 school year and found that the average number of office referrals per week for student behavior was 8, with a standard deviation of 2.6. So I'm just going to off to the side here put n is 15 weeks. Of those weeks, an average of 8 office referrals per week, and the sample standard deviation was 2.6. It tells us a neighboring school reported having 9.3 office referrals per week. Alright, so it's kind of implied here. The question, I suppose, down here is the difference statistically significant? We want to see if our referrals are less than the neighboring school. So we're comparing our sample data against what value? Well, we're comparing our sample data against 9.3. So mu is 9.3. Why? Because this is the sample. This is the data we're comparing our sample mean against. So we know our sample mean is less than 9.3. The question is our population less than 9.3? So mu, in this case, is office referrals at West Elementary. So the population average of the number of office referrals at West Elementary. We want to see, is that less than 9.3? So we're going to run our test, stat, over to test, t-test. We're going to put statistics in. This time for mu naught, we're going to put 9.3. X bar is 8. Standard deviation is 2.6. And the sample size is 15 weeks. This time we want to test to see, is mu less than mu naught. So we select that and we hit calculate. We get a p-value of 0.037 if I round. And remember, we want to compare this to 5% or 0.05. So is this considered to be a low p-value by statisticians or a high p-value? Hopefully you're thinking low. It is. And so what that means is, if mu was actually equal to 9.3, then the probability of getting a sample average of 8 is low. We then conclude that the population mean must be, I did that the wrong direction, guys, I'm sorry. Must be less than 9.3. So then the question, is the difference statistically significant? The answer is yes. We can say that the population mean for the number of office referrals per week is lower at West Elementary. Alright, let's take a look at number 8. Mrs. Miller was involved with a professional development program focused on using student thinking during teaching. She recorded 3 of her lessons and found that, on average, she asked her students to explain their thinking 6.2 times. The research she was reading reported that teachers asked students to explain their thinking an average of 4.5 times. what is mu for this situation? If we read on, which test should we use if we want to determine if Mrs. Miller questions her students significantly more than other teachers? And so you can think of this as Mrs. Miller collecting data on 3 of her lessons. So her sample size is 3, her sample average is 6.2, and her standard deviation is 3.8. Now, we can see that 6.2 is higher than 4.5. So clearly for these 3 lessons, she asked more questions than the average. But the question we're really interested in is mu greater than 4.5? And in this case, mu is the average, the population average number of questions asked, and specifically here by Mrs. Miller. So if we were to look at all of the lessons that Mrs. Miller asked and look at all the questions she asked, how often would she ask questions focused on her students explaining their thinking? Okay, so we're comparing her data, the sample data, to 4.5. So in this case, mu naught is 4.5. Why? This is what we compare the sample data to. Which test do we know if her population average is more than other teachers? Well, her population average is more than 4.5, so we're going to use this one. Why? We want to know if her population average is more than 4.5. So we're going to run our test again. Stat over to test. Number 2, t-test. Mu naught, we're comparing her data against 4.5. She had 6.2. Sample average, or sample standard deviation, 3.8. And n is 3. She had 3 lessons. And we know if hers is greater than. So we calculate that. And we find the p-value is 0.26. How does this compare to 5%? Well, statisticians would call this a high probability. And so what this means is if her population average, mu, was equal to 4.5, the probability of getting x bar equal to 6.2 is roughly 26%. And so we can't conclude that her population average is different. We have to say mu is not significantly higher than 4.5. Now, it could be, if we looked at all of her lessons and we found her population average, it actually could be higher than 4.5. We just can't conclude that based on this sample. So hopefully this has been helpful. Thanks for all your hard work and effort. I appreciate it.